Hello class of 2018. Today we're looking at solving word problems using normal distribution or inverse normal distribution, and we're going to find standard deviation or the mean or both from the information given. So here we have a problem where we're given that x is a normally distributed continuous random variable. We're given the mean of x, but we're not given the standard deviation of x, but we're given one piece of information. So I'm going to draw that so that I see what I'm doing. So I have x here, and the mean is 52.3, and I know that 48 is less than 52.3, and the area under here is 0.229. Alright, now, because we are not told the standard deviation, we can't use the inverse normal function. So I'm going to relate x with z by having this z-axis down here, and so this lines up perfectly with the mean for x, and we don't know how big the standard deviation is. But what we can do is use the inverse normal function with z and find out what gives me a probability of 0.229. So we can use what we have. So z is less than some mystery number, let's call it m or n, equals 0.229, and we use our inverse normal and we'll find that n equals negative 0.742144. So then we reuse this value for z and relate it to the 48 by the formula previously seen. Z equals x minus mu over sigma. Our z value is n in this case, so it's negative 0.742144. Our x value is 48. Our mean is 52.3, and our sigma is unknown. Now, you can choose to solve this by hand or by calculator. If you choose to do it by calculator, you just need to make sure you have brackets around here. I'm going to do it by hand, so let's see how we go. So my first thing to do is to swap sigma with the term over here. And then I can just plug all that in and work out what sigma is. So I have negative 4.3 over negative 0.742144. If I use the exact value from the calculator, I get 5.79402. It's probably safe to round it off to 2 decimal places. Now here we have another classic problem. We have a normal distribution. We've been told 2 pieces of information this time, and we're being asked to find the mean and the standard deviation. So once again, I'll draw my pictures to show what I'm doing. I have no idea what the mean is, but I'll mark it in like so. And 10% weigh more than 24.35, so 10% is over here, and that's 24.35. And the other picture is over here, and we'll have the mean again, and 15% weigh less than 7.14, so it's down here, that's 7.14, and that's 15%. Obviously it's not a perfect picture because I think the 7.14 should be closer to here. Alright, so again I will relate this to the z-axis because that's how I'll find out what these numbers are. And again I have the mean lined up with the 0 for the z's, and I'm going to call these numbers 24.35, let's call that b, and let's call that a, which lines up with 7.14. I do need to use the cumulative inverse normal to get A and B. So for what I need to actually flip that around. So I have 0, B, and everything on Z. And this I need to be 90% or 0.90. Then if I use the inverse cumulative normal, I will get a value for B. That value is 1.28155. And then if I do the same thing on the right hand side here, I'll get an A value. A equals negative 1.03643. So now I'll have two equations and I'll be able to solve the two simultaneously to get the mean and the standard deviation at the same time using the conversion formula. So here I have my two pieces of information and I'm going to substitute this pair of information into here. That would be my Z value for X being 24.35. So we have 1.28155 equals 24.35 minus mu over sigma. And then the second set of information, this is my Z value here for X being 7.14. So I have negative 1.03643 equals 7.14 minus mean over sigma. I could do this by hand, but I think I'll just do the calculator. You could do it by hand by making the sigma the subject and then make them equal to each other. So after a little bit of work from the calculator, I get that the mean is 14.835 and the standard deviation is 7.42457. And that makes sense because this B value is 1, so it's greater than the mean, so it should be bigger than 14, which it is. And then here this is less than the mean, so we expect that 7.14 is less than the mean, which is this, which is great.